odds and ends that we need to clear up before we move on to the next topic. So as far as control flow is concerned, one of the things that happens when you have a counter-controlled loop, and this actually could be true for any kind of loop, actually, is you might be in the middle of a loop and you might want to get out of not only the loop you're currently in, but maybe another loop or several loops. So when you're in this situation and you're using a language like a C-based language, it's a little awkward. So I want you to try it. Look at this loop, and what I'd like to do is these two for loops. I'd like to exit both loops when the sum is greater than 1,000. And I want to do it without altering any of the loop parameters. All right. So think about this for a moment, hit pause and give it a shot. Okay. Now you may have been thinking, hey, let's use break. That's a great idea. So let me put a break in here. So if sum is greater than 1,000, then break. Okay, fantastic. The only problem is if we break right there, then we're going to go back and execute the code in the outer for loop, and then we're going to end up back in that inner for loop again, and we're going to add more to sum, which we don't want to do. What to do? Well, we could add a second break statement right here. If sum is greater than 1,000, then break. Okay, well, that's all right, but it doesn't feel clean to me. So is there a better way? Well, if you're using Java or C or C++, the answer is no. But if you're using C#, hey, now we're talking. Yeah, you can do it. There's a special kind of break. You see this break right here? This is a combination of a break and a go-to statement. So what we're saying here is we're saying break and go to the label both loops. And that will take you here to both loops. So you can quit out of both of those for loops. And you could set that label anywhere you want. If you had a loop inside a loop inside a loop, you could break out of all three. Maybe if you had an if statement that was 4 nested loops deep, you could break out of 3 of the 4 nested loops. You get a lot of choices when you use this type of break statement. So that's really cool. All right. So another interesting sort of tidbit that we might want to consider is, well, let's take a look at this. So we often have situations where we have a collection and we'd like to iterate across the collection. So one of the tools that you can do that with that is to iterate across a collection is a for each statement. So a for each statement would look something like, well, let's say we had okay. So let's say we had a collection of suits, all right? So we could say for suit, sorry about that. For suit in the collection suits, all right? So suit is an item in suits, and we're going to create a rank. Oops. Let's go back here. Or rank in a collection of ranks. And then we're going to create a deck of cards. So sorted deck dot add new card, which takes a suit and a rank. So this is a Java example of using, whoops, the for each statement. Well, basically sort of for each, but you don't have to say for each, you just say for. So the code allows you to cycle through a collection. The collection is returning a particular item in the collection, which we're linking to suit. And then we're doing the same thing again. In this case, we've got suit, which would be a club, an ace, spade, or a heart. And we've got the ranks, which are the 2 through 10, ace, king, queen, jack. Not quite the right order, but you get the idea. So this will allow us to create a brand new deck of cards, basically in order, assuming that we have the suits and ranks in order. So that's pretty convenient. But there are other ways to iterate through data structure collections. And so another example that you can see in Java, and we'll go back to that C# or C++ thing in a second, is something called an iterator. So this is not, I would say many of the languages that you've worked with, Python and Java, you can avoid working with this iterator, but you do encounter this in some languages sometimes. So it's something you should be aware of. So here is an array list. Okay, that's our Java, the Java array that allows us to add, make the array as many elements as we want. If we want to add things to that array list, we've got 3 elements that we're adding to the array list right here. And now what I'd like to do is I'd like to iterate over that, all right? And so what I can do is I can use a for loop and I can request something called an iterator. So I'm going to say set I equal to the iterator for this list. So now I is a special variable. It's kind of like a counter, but not exactly. And it has a couple different things that you can do with it. So one is you can say I, is there another element in the collection that could be processed? So that's what has next is for. So this will either return true or false. If there isn't another element in the collection, then has next will return false, in which case you're basically done iterating over the list. The other thing you can do is you can say, I, give me your next element. So when we start out with iterator I equal to list iterator, remember, I is not, and this is something that's really important, I is not the element hello, all right? We're interested in hello, but I is not the element hello. So what we're going to do is I'm going to say the first I dot next should return hello. The second I dot next will return world. The third I dot next will return exclamation point. Okay, so the fourth I dot next, we won't actually do that. If we did I dot next a fourth time, that would be an error. So after we do the I dot next to get the exclamation point, when we say I dot has next, that will return false, indicating that there are no more elements to iterate over.